All right, so now I want to show you an example where when we solve now for our rational equation, it's not going to have a solution here. Okay, so let's go ahead and follow our 4 steps here that we learned from our last example, and we'll see what happens here. Great, so let's just first determine the domain of the variable. And basically, we just set all of our denominators equal to 0. So we set this guy equal to 0. T minus 7 equals 0. Set this guy equal to 0. T plus 7 equals 0. And this guy, t squared minus 49 equals 0. Well, if I solve for t here, add 7. So that means t is equal to 7. Subtract 7 on both sides, so I get t equals negative 7. And remember, t squared minus 49 is the same thing as the factor form of t minus 7 and t plus 7. Okay, but if I just add 49 to both sides, I get t squared equals 49. And if I take the square root now of both sides, I get t equals plus or minus 7. So I kind of have a repeat here. I have 7, negative 7, and then I have plus or minus 7. So this is the same thing, right? So our domain, again, when we learn from example 1, is that we say x for all values of x such that x is a real value, but x is not equal to, okay, so x is not equal to 7 and negative 7. Okay, or you could say plus or minus 7 like this guy right here. But so basically x cannot be 7 or negative 7. Why? Well, look, if I plug in 7 right here, what does that make my denominator? Undefined, right? You cannot have a 0 in the denominator. It's not possible. Same thing right here. If we had negative 7, that would give us a 0 in the denominator. Okay, so we've done step 1 right here, which is to find the domain. Okay, so x cannot be 7 or negative 7. Which then leads us to, what is our lowest common denominator? Okay, well, if you think about it here, if this is x minus 7, this is, I'm sorry, t minus 7, this is t plus 7, and this right here is t plus 7, t minus 7, right? That's what this means, which means that our lowest common denominator is going to be that t plus 7 and t minus 7. You see that there? Because this right here is t plus 7, t minus 7. That's what t squared minus 49 is when you factor it. So that means this side has t plus 7, t minus 7. This only has a t plus 7, so I have to multiply this one by t plus 7, or I'm sorry, t minus 7. And this one I need to multiply by a t plus 7 to have a common denominator. Okay, so the way that this works now is in step 2 is multiply everything by our common denominator, or at least common denominator of t plus 7 and t minus 7. Okay, so let's go ahead and do that over here. I'm going to go ahead and do that in blue here. So I'm going to do t plus 7, t minus 7. I'm going to multiply that by my first term. See this right here? 1 over t minus 7. Okay? And then I'm going to do plus, I'm going to multiply again, t plus 7, t minus 7. I'm going to multiply that by our second term, 2 over t plus 7. One more time, I'm going to take our LCD, t plus 7 and t minus 7, multiply that by our last term here, 14 over t squared minus 49. Okay, so now we get some cool little crossing out that happens here. It's right here, t minus 7 and t minus 7. What the? So all I have left is t plus 7 now, right? All I have is t plus 7 left. Cool. Right here, the t plus 7 and the t plus 7 cancels. So I have 2 times t plus a 2t, and a 2 times negative 7, negative 14. Okay? Is equal to, well, t squared minus 49 is t plus 7, t minus 7. So those just all cancel out, and we're left with just 14. Okay, so now we do some simplifying here. We can add the 2t and t, so that's 3t. I don't know, I could do 14. That's a negative 7 equals 14, right? 7 minus 14 is negative 7. Then I add 7 to both sides. So 3t equals 21. Divide both sides by 3. And t equals 7. Okay? And that's where the red flag should come up. Woo, woo. Right? Because when we come back up here, wait a minute, our domain tells us that it cannot be 7 or negative 7. That is not possible. Right? So really, you can kind of stop right there after we've done step 1 and now we've done step 3. There's no need to plug it back in. I mean, if you plug in 7 right here, we're going to see that it's not going to be possible because we have 0 in the denominator.